Hi everyone, welcome back to my channel. So many students while starting to do the SV course will have this one question in their mind, like how much time it actually takes to complete the SV course, and can we get hold of all concepts in System Verilog within 2 to 3 months after starting the course? Like this is the most frequently asked question to me by the students, like how much time it takes to complete the SV course entirely, like in order to get a good hold on how to develop a test bench code on SV, how much time does it takes? Yes, it almost takes 2 to 3 months of time. If you daily give 2 hours of your time for this particular course, then it takes nearly 2 to 3 months of time in order to have a good and thorough knowledge on all the concepts of System Verilog course, right? So in today's video we are going to talk about how what are the references, what are the reference sites that you could refer to in order to have a knowledge on this particular course, SV course, and what are the important concepts in SV. So everything that is related to System Verilog HDL, like consider it as a roadmap for System Verilog HDL, right? So before getting into today's video, if you are new to this channel, consider subscribing my channel and hit on the notification bell also, so that as soon as I upload the video you'll get the notification. And also if you like this video, please do give it a like, so that it is helpful for me in order to create more such content on these courses like Verilog, System Verilog and UVM also. And you can join my Telegram channel for the courseware related to these courses, right? So getting into today's video, as I told you, first before getting into System Verilog HDL, you should get ready and you should brush up your knowledge on the concepts in digital design and Verilog HDL. So you should brush up all the concepts in digital design like combinational circuits, sequential circuits, which includes like counters, flip-flops. So all these things you should have a good thorough knowledge on digital design concepts. And then, since everybody know that System Verilog is just an extension for Verilog HDL, okay, along with Verilog HDL concepts you are having many more enhanced concepts in System Verilog, which is why before entering into System Verilog you should first brush up all the concepts within Verilog HDL also. So these are the two concepts that you should be thoroughly getting into before going into the System Verilog HDL. That is first digital design and then Verilog HDL concepts. Now coming to the what are the reference, what are the sites that you could refer to in order to have the material on this particular System Verilog and Verilog courses also. You can refer to Chip Verify, or you can go for ASIC World, you can go for VLSI Verify and Test Bench also. Like you can refer to all these based on your way of learning the concept. You can just refer to all these four websites in order to have a particular material on all the System Verilog and Verilog courses. And you can also see into my channel where I have made entire videos on both Verilog and System Verilog also. I link those in the description box. You can go there and check it out. I have made a separate playlist for this Verilog HDL as well as System Verilog also. And within Verilog also, and within System Verilog also, I have made separate playlist for oops concepts, for assertions. In this way I have created separate playlists for every each and every important concept groups, right? So you can refer to all those playlists if you enter into my YouTube channel. Okay, so my YouTube channel is VLSI to you. You can just go there and check it out, right? So but if you want in a book format, instead of going to this websites, if you are someone who is interested in reading a book, then you can get this book titled System Verilog for Verification by Chris Peer. Okay, you can get your hands on this book, Chris Peer, which is System Verilog for Verification title, and you can just check all the concepts from that particular book, right? So these are the reference sites that you could, there are many more sites also, but according to me these are the perfect websites if you are a beginner or if you are someone who are interested in doing a System Verilog course. Then these are the perfect websites for the beginners, right? So these are the things that you could refer to. And then coming to the important concepts that you need to concentrate on if you are a beginner, that means what I can say is you should put entire 70% of your time on these particular concepts. Okay, and then the remaining is for the and the remaining time on the remaining concepts and the codes also, right? So the first thing is data types within system Verilog, because in Verilog you are having very less data types compared to that of system Verilog. In system Verilog there are many enhanced data types, and also in system Verilog it is categorized into predefined and user defined data types also. So what are the kinds of user defined data types and what are the predefined data types? So all these things you should know before entering, before this is the concept in system Verilog, because these are the most frequently asked interview questions within your system Verilog interviews. So that is why you should have a good hold on data types. And then basic oops. Okay, so if you see all the concepts like enhanced data types and oops, randomization, threads and interprocess communication, so all these are the concepts that were introduced in system Verilog rather than Verilog, because you don't see any of these concepts in your Verilog HTL course. Okay, so these are the enhanced concepts in system Verilog which you need to put your entire time on in order to develop the test bench. Because when you're the code for your system Verilog, when you're writing a verification code, when you're writing the generator code, when you're writing the transaction code, when you're writing the interface code, so in when you're writing all these codes you will use all these concepts on basic oops, randomization, threads, interprocess communication. So all these things you will be using in order to develop your code. That is why these concepts are very important in your system Verilog, right? So basic oops concepts, like which include inheritance, encapsulation, polymorphism, abstraction, so all these concepts. And then randomization and constraints also. So within randomization you will be having your constraint based randomization, because basically in system Verilog you will be using the constraint based randomization, right? So the third important concept is randomization and constraints. And then threads and interprocess communication. So threads means which includes threads and interprocess communications includes like fork and join threads. Okay, fork join, any fork join, non threads. And interprocess communication which includes like events, semaphores, mailbox. So all these concepts you will be are included in this threads and interprocess communications concept, right? And then debugging techniques. So basically system Verilog there are many enhanced debugging techniques which includes assertions, coverage, waveforms. So by using all these concepts you will be the debugging techniques within system Verilog is very enhanced compared to that of Verilog, right? So these are the techniques, these are the important concepts that you need to put 70% of your time in order to have a good knowledge on all these concepts. Okay, if you are someone, if you are a beginner to this SV course, okay, please do check this out whether you are putting your time on this particular important concepts like data types, oops or randomization, because while doing the course, okay, it is very important to know what are the actual concepts and what are the important concepts within them, where we must put your entire time on in order to have a good knowledge on that particular course, right? Hope this video is helpful for you. If you are someone who are interested in system Verilog, doing system Verilog course, and you can also refer to my classes in system Verilog. I hope they may be helpful for you in order to have a knowledge on the system Verilog concepts, right? So now after completing all these basic chapters, like as we have discussed, after completing all these courses, then start practicing examples. That also I have made a video on this course. Presently I'm running on it, right? I have made a separate, I'm writing a, we are I and you together are writing a codes on particular concepts, like every concept in detail I'm explaining it with a code. Okay, until now I have explained some 6 to 7 concept codes, like shallow, which includes shallow copy, deep copy, how to write a code for shallow copy, how to write a code for deep copy, and how to write a arrays, how to write a code while by using arrays. So all these things I have explained in that. I'll link that codes playlist also in the description box. You can go there and check it out in order to refer the code examples in system verilog. Okay, so after completing all these courses, try to practice codes. Okay, because after all, reading, after entirely having the knowledge on concepts, the most important thing that you should need is writing a code. Okay, coding is very important for design and verification engineer. So how much you learn, if you put it in a format of code only, then only you can understand. So practicing codes is very important. And then after practicing the codes, then try to do some sample projects in system verilog. Okay, you are having today various, as we have discussed before, there are various resources, online resources, where you could find the sample projects. Okay, like designing a memory in system verilog. In this way you are having various sample projects where you can use the online resources help, and you can write a code. Okay, presently we are in the place where we are writing a developing a test bench code for adder. So after this we will be developing a test bench code for memory. I'll also link that in the description box. You can go there and check it out, right? And then after doing all these things, the one and last important step before going or attending any interview, try to solve the various interview questions. If you see, before I have told you, like these websites like chip verify, vlsa verify, test wins. So every website here that you have mentioned consists of some important interview questions, like most frequently asked interview questions. And if you see some websites like vlsa verify or chip verify, they has again categorized this particular interview questions in basic level, advanced level, and higher level. Okay, in this way, if you are having this particular websites, if you see these websites, you will be trying, you can try to solve the interview questions by taking the help of this particular online resources, right? So in this way you can improve your system verilog course. If you are doing the system verilog course in the way that I have mentioned, then within 2 to 3 months of time you will be getting the good knowledge on system verilog course, right? So this is the roadmap for the system verilog to the students who doesn't know anything about system verilog and are starting from zero in coming to system verilog course. Okay, so this is the way you should plan your system verilog course. If you are someone who are taking some online resources help in order to do this course, then this is the way you should this is the roadmap for you in order to reach your entire in order to reach your goal, and in order to cover the entire concepts in system verilog, right? So this is the thing. If you are having any other doubts related to system verilog course, feel free to ask me in the comment box. I'll definitely reply to your answer, I'll definitely reply to your questions. And so this is all for today. If you like this video, please do give it a like, and also share it to all the VLSI aspirants who also want to enter into design and verification domain, and who want to do the system verilog course, right? So this is all for today. Thank you.